Hello, ladies and gentlemen. I'm very happy to welcome you to today's lecture on training and education in the solar sector. First of all, of course, I would like to thank the International Solar Alliance and the Clean Energy Solutions Center who facilitate this webinar series. Some background from me before I joined it, 2010 factor. I have been Director of Policy Finance in the International Renewable Energy Agency, IRENA. There, I was responsible for the project called IREP, IRENA Renewable Energy Learning Partnership, that has the main objective of improving, increasing, and facilitating access to renewable energy, education, and training. In this lecture, we are continuing the discussion on socio-economic aspects of solar energies that we, as part of the Module 6 of the full lecture program. In this module, we will start with the definition of what education and training is and a brief discussion on the importance of education and training in the solar sector. Afterwards, we will jump into the main body of the presentation. Don't forget, at the end of the presentation, you will be given the chance to test your knowledge with a little quiz. The learning objective that this lecture provides will consist in having an overview of the education and training situation for renewables and solar in particular, an overview of the training offer, the most required profiles in the solar sector, and policies and recommendations for increasing and improving education and training in solar. As per the International Renewable Energy Agency, IRENA, at the end of 2017, it was estimated that there was 10.3 million people employed in the renewable energy sector, directly or indirectly. The technology employing the most, it is the photovoltaic, with more than 3.3 million jobs. In addition, solar thermal for heating employs 0.8 million people. Qualified human resources are needed all along the value chain: project planning, manufacturing, installation, operation and maintenance, and the commission. But on the other hand, we see here a graph by the European Wind Power Associations that show how in Europe the percentage of new professionals with studies in science, technology, engineering, and mathematics continues to be lower than the market demand and very constant. We have to take into consideration that given the distinctness of renewable energy production technologies is a sector that demands highly qualified specific skill. In addition, the renewable energy industry, and the solar in particular, has to deal with workforce that is not easily transferable, neither from conventional to renewable energies, nor within different renewable energy sectors or technologies. Today, we are facing a scarcity of qualified human resources, and this is an obvious barrier to technology dissemination. Adverse effects of deficient training of solar technologies, or both the public and professionals, may manifest itself through an increase in the cost, inefficient utilization, and a bad reputation for solar technologies. Education is defined as the transmission of knowledge to a person so that he or she acquires a certain information. And training It is the process of which the skills needed for a particular job activity are gathered. After this brief introduction, we can jump now to the main body of presentation. The first part of the lecture is devoted to provide insight on the existing offer of education and training. The information summarizes a recent research article, being one of the few structured work addressing the challenge of scarcity of professionals in the renewable energy sector in general. Methodology used in the research was in three phases: a literature review, an analysis and assessment of the most comprehensive database of renewable energy education and training, the IRENA Renewable Energy Learning Partnership IREN database, and finally, interviews with professionals from the renewable energy education sector or responsible for human resources in renewable energy companies. Regarding geographical distribution of the education, first finding of the paper is that the more acute shortage is in developing countries. 40% of the datasets are from Europe, 33% from North America, 6% from Africa. This raises concerns if we compare with the resource potential or with the declared targets in the national determining contribution of African countries. Most common cited challenges to increase education and training in developing countries are financial constraint, shortage of qualified teachers and trainers, lack of know-how in developing curricula. There is a very important mismatch between education offer and industry demand, for instance, on the technological scope of the training. Project development, operation and maintenance, construction and installation, and manufacturing for wind and photovoltaic demand hands-on training, but 32% of the dataset are master level, and only 16% are categorized as vocational training. When recruiting for managerial position, the experience is more important than the academic background. Reasons highlighted in the interviews are the size of the solar market and structure. The solar sector relies heavily on subcontracting, and subcontractors do not talk with academia, so there is a lack of developing curricular and hands-on training. There is as well another mismatch between education offer and industry demand on the technological scope of the training. More than half of the offer have multi-technology curricula. There is a low percentage of jobs within the sector that demand a broad overview of renewables, wind and PV demand specialists in the field and in these technologies. From the interviews, more interesting than multi-technology is the interaction with solar technologies in buildings. And there is a great demand for professionals that can integrate solar technologies in different aspects, also for heating and cooling, and also for transport. Very low offer on hydropower. It is because it is already incorporated in existing engineering curriculum around the world. And finally, regarding geothermal, it may look comparatively low, the offer in education, 3.8% of all the education provided in renewables. But this is concentrated in the countries with higher resources, United States of America, Iceland, Germany, New Zealand, Japan, with two notable exceptions, the Rift Valley in Africa and more accurate in the Andean region. One of the challenges of increasing professionals is the need to increase awareness. The research done on education in renewable energy also studies the interest of professional students in the renewable energy sector. Students and professionals from other sectors, they are not aware of the opportunities in the solar sector, and they don't know where to look for the most suited education. There is a need to facilitate access to education and training. The research analysis using Google Analytics states that the users of the database are interested in education and training in renewable energies. Most of them are coming from Asia and Europe, and there are people in the group of age of 25 to 34 years. While 40% of the inquiries are coming from Africa may look low, taking into consideration the number of renewable energy education and training opportunities currently available in the region and the lower internet access, the level of interest in Africa should be considered high. The very low level of inquiries coming from North America suggests that the IRENA Renewable Energy Learning Partnership Database was not the gateway to renewable energy education and training in the region. Inquiries by age follow the same pattern as similar sectors of the economy. There are slightly more male users than female, with 54% male and 45.8% female. The higher level of interest from women in renewable energy education compared with conventional energy, or compared, for instance, with a graduate in science, technology, energy, and mathematics. Companies that were interviewed confirmed that they are witnessing an increased percentage of suitable female candidates in hiring processes. Employability of women is higher in the renewables because most people find a job thanks to their professional network. Professional networks in conventional energies were established a long time ago. They are closed and dominated by men. On the education and training shortage. Given relatively high level of skills required and urgent demand to fill occupation, the sector is often faced with a shortage of adequate skills to successfully complete projects. 80% of hiring managers highlight a skill shortage as a key challenge. Requirements change so quickly that the supply of skills that was broadly satisfactory in the past no longer meets requirements, and systems of skill anticipation, coverage counseling, and provision of training and education fail to keep up with change. The growth of the sector can be limited by the system's capacity to provide the labor market with professionals with the profiles that companies require. Currently, most companies are recruiting experienced individuals with comparable skill sets and they from another sectors in another technologies or areas, and then these people is provide job-specific training. This strategy is costly and risky for the sector, which faces dramatic increase in human resource requirements. Recent analysis showed that present level of vacancies in the photovoltaic will continue to happen in the main markets as China, United States of America, and Europe. Most managers and intermediates use referrals and recruitment agencies to find their current role. Juniors resort to a variety of sources to find their jobs. Referral, recruitment, consultancy, LinkedIn, and company websites are being used almost equally, percentage ranging from 20 to 26. Similar to the findings of the research paper on the skills gap, there is an increased demand for professionals that, in addition to solar, know how they have knowledge on other disciplines to integrate solar into systems, energy systems. For instance, in addition to the skill shortage in renewable energy, the types of jobs required in the sector are diversifying into digital and IT. McKinsey published in 2016 that digital optimization could boost profitability by 20 to 30% for power utilities. This can be done through smart meters and smart grid, digital productivity tools for employees, and automation of back-office processes. This also implies the need of creation of solar jobs together with IT jobs. And last but not least, as mentioned previously, developing countries are more affected by the shortage of education and training in the solar sector. One of the faster growing markets in the solar sector is the off-grid sector, both solar home systems and mini-grids. As analyzed by the International Renewable Energy Agency, the solar off-grid sector has a great potential to create direct and indirect jobs, and of course, induce jobs created to the improvement of the economy when provided with power. Aware of this challenge, a global coalition launched Powering Jobs, a multi-year campaign aimed at creating the new energy skills and jobs needed to provide access to cheap, reliable, and clean energy for all. The coalition, backed by Schneider Electric Foundation and the Rockefeller Foundation, is made up of multilateral organizations, educational and training institutions, global energy companies, civil society groups, researchers, and more. Similar to the companies acting in the large-scale solar facility sector, companies in the off-grid sector are trying to overcome the shortage of skills with train on the job. One of the most reputed experiences is the Mobisol Academy. There are three most wanted profiles in PV companies, or that PV companies are looking for. The first is technology researchers for manufacturing, second, field technicians in operation and maintenance, and third, engineers of PV system designer for project planning. With regards to technology researchers for manufacturing, the experience and skills required are a doctoral degree is necessary for science that conduct original research and develop new products. However, some workers may enter the scientific field with a bachelor's or master's degree. Computer skills are essential to perform data analysis, integration, modeling, and testing. The usual responsibilities and duties are: physicists observe, measure, interpret, and develop theory to explain physical phenomena using mathematics. In the solar power industry, physicists work with chemists, materials science, and engineers to improve the efficiency of solar panels. Chemists investigate the properties, composition, and structure of matter and the law that govern the reaction of substance to each other. Using this knowledge, chemists in the solar power industry are able to improve on solar cell design, develop new materials or organic components. Materials science study the structures and chemical properties of various materials to develop new products or enhance existing ones. With regards to field technician, operation and maintenance, the experience and skill required are working knowledge of troubleshooting electrical components and equipment, effective written and verbal communication skills, a minimum of a couple of years experience in the solar power operation and maintenance. Most commonly, the responsibilities and duties of a field technician are maintain all tools, saws, vehicle, and all work locations in a safe and efficient condition. Provide inspection of watch, mechanical, electrical, and electronic troubleshooting for a PV field and associated equipment. Job may include other miscellaneous duties are assigned. With regards to engineers for project planning, the experience and skill required are master degree in an engineering-related field or master degree in non-engineering field and 1 year of solar industry experience, or a degree in design-related field, 1 year of solar design experience. Proficiency in AutoCAD, basic knowledge of residential construction techniques, critical thinking and availability to solve problems. The most common responsibilities and duties are create, review, and modify drawing sets in AutoCAD and custom software tools, complete electrical and structural design for photovoltaic projects, research, document, and comply with local and national code requirements in project jurisdiction, coordinate with site assessors, project management, and sales teams to complete design meeting the customer's specification with strict deadlines, assist in documenting and developing industry best practices, standards, and guidelines, delegate project completion tasks to other engineering team members, utilize software systems to record progress of various tasks. The three most wanted profiles for concentrated solar power companies are technology researchers, chief sales and marketing officers, solar thermal operation and maintenance technicians. With regard to technology researcher in the field of concentrated solar power, the experience and skill required are a PhD in a relevant field of science of engineering, such as mechanical engineering, chemical engineering, process engineering, electrical engineering, and experimental physics. High level of organizational, analytical, and problem-solving skills. Proficiency in spoken and written English is essential. Instrumentation, control system, computational and experimental fluid mechanics, thermal storage devices, high temperature engineering. Most commonly, the responsibilities and duties in these jobs position are design, construction, testing, and optimization of experimental components associated with the CSP receivers, solar thermal energy storage, the development or adaptation of modeling, optimization, and control system for a concentrated solar power plant, working with sensors, data analysis, and modeling aimed at improving the efficiency of CSP system. Finally, modeling of CSP system and or techno-economic studies. With regards to chief sales and marketing officers, the experience and skill required are a strong track record in technical sales, business development, proven track record in building and leading marketing sales teams, experience managing the entire sales process and reporting relevant sales metrics, negotiation skills, a strong organizational and public speaking communication skills, thorough understanding of a demand-supply perspective, and well-established relationship with potential customers. With regards to the most common responsibilities and duties, development, implementation, and execution of the marketing policy and marketing plan, business development of new markets and products, including new business ventures, sales activities, from acquisition to contract closure, management of the sales team and agents, communication with industry, organization, and stakeholders, management of commercial aspects of ongoing projects, after sales activities and development, sales, business plan development, and execution. With regards to chief sales and marketing officer, the experience and skill required are good physical condition, availability and willingness to work in hot, dry, and dusty environments, interest in the practical application of technology and hands-on work, availability and knowledge to use maintenance tools effectively, With regards to the most common responsibility and duties, a good chief sales and marketing officer will provide inspection, electrical and mechanical repairs, as well as a good operation and maintenance technician will provide inspection, electrical and mechanical repairs, as well as electronic and mechanical troubleshooting for operating solar fields. Will maintain all tool shops, vehicle, and work location in a safe and efficient condition. Reading schematic diagrams and technical documents to determine methods and sequences for the work. Installing parts and components in the power plant. Operating or controlling machinery that generates heat and electric power using computer or semi-automatic equipment. Examine and testing steam and electrical power distribution machinery and equipment using testing device. Maintaining and repairing steam and electrical power machinery and equipment using hand tools and ensuring safety of oneself and others by following safety procedures. We come now to the part of the lecture regarding policy recommendation to improve, increase, and facilitate access to education and training. The first is on strategic planning for skill needs, education, and training. Both quantitative and qualitative skills needs assessment has to be done before designing a training and skill development policy. There are several handbooks and tools already developed by the international agencies that will provide guidance to assess the needs of qualified professionals when developing the photovoltaic sector and the concentrated solar power sector. Incorporating renewable energy into technical and tertiary curricula. To complement the postgraduate offer, vocational education and training can be a good response to the skill gaps, since it will help workers coming from other fields to specialize in the sector, building on skills they have already acquired from previous experience. It should provide adequate basis, transversal, and vocational skills that fit the needs of employers, but also equip learners to engage in long-life learning and to manage transition from education to employment, as well as from one job to another or from unemployment to employment, developing training institutes and centers of excellence, providing financial support, grants and fiscal measures to professionals willing to further train. According to the Global Energy Talent Index, 59% of employers in the renewable energy believe they can overcome the skill gap with additional training and development, 45% with graduates and apprenticeships. Fostering public-private partnership. Partnership between companies and the academia is highly recommended to raise graduate awareness and train them accordingly. Furthermore, there is a need to support train in the job activities, in particular the dual education. Dual education is an opportunity for future employees to learn. The concept of accumulated experience is important, as employees will be able to reuse the excess knowledge generated in the process in a new context in the future. For companies, by maintaining accumulated know-how in-house, it will limit the use of a skill shortage in case of turnover. Regulatory demand-driven measures, for instance, mandatory certified installers for renewable energy in buildings, can be a very proactive way to increase and improve education and training. Standardization and accreditation of qualification. Harmonized curricula and qualification across countries can be helpful for reducing the time needed to react to market signal, easing companies' workforce selection, and facilitating mobility of students and workers. Common quality standards make it possible to evaluate training programs in an accreditation process against a set of defined requirements for competency, quality management, required resources, and qualification. We come now to the concluding remarks. The workforce deficit and the skill gap in renewable energy industries around the world need to be addressed urgently. There is a critical shortage of skilled personnel to develop, design, finance, build, operate, and maintain solar projects. Currently, education and training opportunities in solar technologies are scarce, concentrated in a few industrialized countries. There is a need for comprehensive education and training policies based on capacity needs assessment. There is a need for more technology-specific hands-on training. In addition to improving solar education and training, attracting female workers to renewables will facilitate to reduce the scarcity of professionals. And now to the end to the lecture, and as usual, you can test your knowledge in a small following kit. Thank you very much.